Hello students, for class 9, today I am going to start number system. Number system. This is unit 1. And subtopic is real numbers. The chapter consists of 8 marks. The chapter consists of 8 marks. The chapter consists of 8 marks. Now, in number system, first let us know natural numbers. Natural numbers. Now, what are natural numbers? The collection of counting numbers is called natural numbers. The collection of counting numbers, the collection of counting numbers is called natural numbers. Natural numbers is represented by capital N. Hence, N is equal to second bracket 1, 2, 3, 4, dot dot dot. Now, whole numbers. What are whole numbers? If 0 is included in the collection of natural numbers, we get the collection of whole numbers. Again, evaluation. If 0 is included in the collection of natural numbers, we get the collection of whole numbers. Whole numbers, it is denoted by capital W. And hence, capital W is equal to, within curly bracket, 0, 1, 2, 3, 4 and so on. Next, integers. Integers. Integers means a collection including natural numbers 0 and now integers. What are integers? A collection including natural numbers 0 and negatives of natural numbers is called the set of integers. It is denoted by capital letter Z or I. Capital letter Z or I. Z comes from the German word Zählen, J-A-H-L-E-N, Zählen, which means to count. Now Z or I is equal to -3, -2, -1, 0, 1, 2, 3, dot dot dot, and so on. So integers, these are countless. Infinite number of integers are there. Similarly, whole numbers, infinite number of whole numbers are there. Similarly, natural numbers, infinite number of natural numbers are there. This collection includes, the integers. This collection includes natural numbers and whole numbers. Numbers, now we are going to discuss rational numbers. Rational numbers. Now, what are rational numbers? Numbers which can be written in the form of P by Q, where P and Q are integers. And denominator Q not equal to 0, and P and Q are co-prime integers. So we can write P and Q are co-prime integers. Co-prime integers. Now I think you all know co-prime. Two numbers are called co-primes if between the two numbers there are no common factors except one. They are called co-prime integers. Rational numbers are denoted by capital Q. Rational numbers are denoted by capital Q. All integers can be written in the form of P by Q. Hence, we can say that all integers are rational numbers. I think at this very moment you all are thinking 0 is an integer. So how 0 can be a rational number? Okay. 0 can be written as 0 by 1. Now P, Q in the form of P by Q. So P is 0 and Q is 1. Both are co-prime integers, and Q 1 not equal to 0. Similarly, negative numbers can also be written as negative, that is -3 can be written as -3 by 1. Hence, in the form of P by Q and Q not equal to 0. Therefore, these are all rational numbers. Collection of rational numbers includes integers, also whole numbers and natural numbers are collected within rational numbers. Now, the numbers natural number, whole number, integers, rational number. We can represent them like this in the form of set. Natural number is the subset of whole number. Again, whole number is the subset of integers. Again, integers are subset of rational numbers. Thus, natural number, whole number, integers, all are subsets of rational numbers. Clear? Now, how to find out rational numbers in between two given rational numbers? Say A and B are rational numbers, then A plus B by 2 is also a rational number and lies between A and B. Now you remember, between any two rational numbers lie an infinite number of rational numbers. An infinite number of rational numbers. Now, this type of sum can be done in another way also. Suppose you were given in between 3 by 5 and 4 by 5, both are rational numbers. You have to write, you are asked to write 5 rational numbers. 5 rational numbers. Now, how to do this? Obviously, suppose this is 3 by 5 and this is 4 by 5. Now we are going to put 1, 2, 3, 4 and 5. 5 rational numbers, say they are R1, R2, R3, R4 and R5. So first let us find out the difference between the rational numbers. When we are to put 5 rational numbers in between two given rational numbers 3 by 5 and 4 by 5, you see that the space between is divided into 1, 2, 3, 4, 5, 6 parts. Here how to solve? Let x is equal to 3 by 5, y is equal to 4 by 5 and y greater than x. N is equal to 5 because you are going to put 5, you are going to write 5 rational numbers. Now let us find out this difference. Let us find out this difference. So d is equal to y minus x by n plus 1. That is equal to 4 by 5 minus 3 by 5 by 5 plus 1. That is equal to 1 by 5 by 6, that is equal to 1 by 30. Therefore, R1 is equal to how much this is greater than 3 by 5 by 1 by 30. So R1 is equal to 3 by 5 plus 1 by 30. 5, 6, 30, 6, 3, 18. So 18 plus 1, 19 by 30. R2. R2 is greater than R1 by D. So R2 is equal to 19 by 30 plus 1 by 30. That is equal to 20 by 30. Similarly, R3 is equal to 20 by 30 plus 1 by 30, that is 21 by 30. Similarly, R4 is equal to 21 by 30 plus 1 by 30, that is equal to 22 upon 30. Now R5 is equal to 22 upon 30 plus 1 by 30, that is equal to 23 by 30. Clear? Some may do the sum in this way. I am showing you one more. Suppose it is 3 by 5. This is 4 by 5. Now 3 by 5, 4 by 5. What is the difference between 4 and 3? 1. Clear? Now, but we have to write 5 rational numbers. So let us write equivalent fraction of 3 by 5. Let us multiply both numerator and denominator by 6, that is 18 by 30. Similarly, 4 by 5 is equal to equivalent fraction 4 by 5 into 6 by 6, that is equal to 24 by 30. Now, between 18 and 24, we can write 5 rational numbers. 5 rational numbers as, what are they? 18, then 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. Now what are given to you? That is, you are given 3 by 5, which is actually 18 by 30, and you are given 4 by 5, which is actually 24 by 30. So in between 3 by 5 and 4 by 5, you are able to write 5 rational numbers: 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30, and so on. So this is also one way to find out the rational numbers in between two given rational numbers. Now irrational numbers. Irrational number means irrational numbers. Irrational number means a number which cannot be written in the form of p by q, where p and q are co-prime integers and denominator q not equal to 0 is called an irrational numbers. Listen again, students. A number which cannot be written in the form of p by q, where p and q are co-prime integers and denominator q not equal to 0 is called an irrational numbers. The square root of a natural number which is not a perfect square is an irrational number. Again listen. Square root of a natural number which is not a perfect square is an irrational number. For example, root 2, root 3, root 5, root 6, root 7, like that. But don't write, remember, don't write under root 4, because under root 4 is equal to, you all know, plus minus 2. There is plus 2 or minus 2. Now plus 2 or minus 2, whatever may be, they are integers. So they are not irrational numbers. Cube root of a number which is not a perfect cube is irrational number. Again listen. Cube root of a number which is not a perfect cube is irrational number. For example, cube root of 2, cube root of 3, cube root of 4, cube root of 5, etc. These are all irrational numbers. Similarly, pi, 1 by pi, 2 pi, pi square, etc. are all irrational. That is irrational numbers. Okay. Now, how to locate root 2, root 3, root 4, root 5, root 6 on the number line. Now let us see. Locate root 2, root 3, root 5, root 6, etc. on the number line. Now let us see how to do that. Say this is the number line and this is 0. This is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, and so on. Now, what we know? Root 2 is equal to under root of 1 square plus 1 square. So, according to Pythagoras formula, this 1 unit we are taking as base. This is base and this is perpendicular. And this 1 unit as perpendicular. We have to draw perpendicular, and you all already know how to draw perpendicular. So this is perpendicular you have drawn, and from this perpendicular you cut off 1 unit. Now you join this. This is obviously root. Now taking O as center and OA as radius, draw an arc. So this is the position of root. Again root 3. How to get root 3? Root 3 means under root of root 2 square plus 1 square. So root 2 square plus 1 square means 2 plus 1, that is equal to root 3. So perpendicular to be taken as 1 and base to be taken as root 2. So from here you draw perpendicular. Cut off 1 unit. Say this is B. Join OB. So obviously this is root 3. Now in the same way, taking O as origin, that is 0 as origin, let us draw an arc. So obviously this is root 3. Now go on doing the same way, you will get the value, that is you can plot root 2, you can locate root 2, root 3, root 5, root 6 on the number line. Similarly for root 5. Root 5. Root 5 means under root of 2 square plus 1 square. So this is base and this is perpendicular. So base is 2 unit, 2 to the 4. 2 square means 4 plus 1 5, so under root 5. So we have to draw a perpendicular here. This is 1 unit. Now join this. Now draw the arc in the same way. So this will be root 5 and so on. Very easy to do. So today in the number system, real numbers, we have learned different types of numbers, how they can be written in the form of set and subset. Though you don't know about set and subset, I have shown you how to represent them. Next, what are rational numbers, what are irrational numbers, how to locate irrational numbers on the number line, and how to write particular numbers of rational numbers in between two given rational numbers. So no more today. You go through the exercise, you go through the discussion, explanation again and again. I think you would like it. Then try to solve the questions that will be given to you as worksheet, which will be very helpful to you, which will help you to learn a lot. Okay, students.